I started posting all of your weekly lecture videos to the podcast, so we're kind of going unstructured, unnumbered.
So Intellect Podcast, unknown number, take 0.
Take 0. Hey, what's up, guys? So we're here with Brad DeMarco, Walker D. Reynolds, and we're about to talk about what are we about to talk about, Walker?
We're about to talk about this podcast is in the vein of the podcast that we did with Easy Automation, with TatSoft, talking about Factory Studio. Brad is the president of a company called Automation Intellect that they provide a level 3, layer 3 solution that is edge driven. And they were introduced to us by Kate Cohen. Anybody who follows the channel, Kate was what was her title at?
She was VP of sales for a while, and
Okay.
then she went back into more of a producer role.
Okay.
And then she ended up as global sales something or other.
Okay. So Kate is Kate. We were introduced to Kate a year ago. We've been talking with you guys maybe 9 or 10 months. We've been trying to put this podcast together. Today's the first time that we've been able to work the schedules out. But Brad is president of a company called Automation Intellect, and what we really want to do is we want to talk about your product, and we want to talk about how it fits into the subjects that we talk about, which are digital transformation, IIoT, and the fourth industrial revolution. So,
Great.
Brad, let's start out with who you are. You want to just give us the Brad DeMarco background.
Yeah. Don't know how far you want to go back, but born and bred mechanical engineer. So I started out kind of as an engineer.
Mm-hmm.
Started my own company about 20 years ago in 1997-ish. And that company designed and built automation. So it was cameras and robots and
Products company.
assembly automation. Kind of white piece of paper, all the way up through completed design with, we did all the build and everything like that. That company still exists, and it was kind of the genesis for Automation Intellect. So that experience of running an automation company was really kind of what led to understanding the need for software and for visibility into the pieces of equipment that we were building.
So you were a machine builder?
Yep.
So you're a machine builder, you were building other people's designs, or other people's ideas, or your ideas, or both?
So it was essentially the customer would come to us with a specification.
Okay.
They have a problem, and we needed to come up with a piece of equipment to solve that problem.
And Automation Intellect, the 30-second elevator pitch of that company?
So that company is really an asset performance management tool that uses OEE as a standard metric to help customers maintain, manage, and improve the performance of their equipment.
Okay. Was that born out of, so obviously, architecturally, do you want to quickly walk through the architecture of Automation Intellect? So I know you got E1s and you have an edge device out on the edge on the machine, and walk us through that architecture.
Yeah, so we connect directly to the PLC with an edge device called an E1. It's a HMS edge device product. The edge device can speak pretty much any industrial protocol that's out there today. And so we connect through that. We pull in the tags directly from the PLC. We don't make any changes to the PLC. We don't do anything unnecessary to the PLC. Pull that data in to the E1. Then we push the data out to the cloud. We're hosted on AWS. We ingest that data into our system and populate our dashboards and our hierarchies for each customer.
And everything's HTML5, mobile ready, out the box.
Yep. We don't have a mobile app, but it's, what do they call it? What's that design?
Web design?
Yeah, it kind of automatically sizes to the device.
Yeah, that's all web development. Yeah, HTML5, it means it's, in ignition terms, it's perspective, right? So
Okay.
it uses CSS backend to give priority to objects and align them for mobile devices.
I have a question. So Brad, I want to kind of take a step back. You mentioned APM earlier. You want to talk a little bit about what that is and how that is used for business?
So it's a term that we learned actually from Gardner. So we are engaged with Gardner and trying to figure out this space, because I came at it from an engineering perspective, wasn't really coming at it from a software knowledge perspective. And so as we looked at the space, IIoT is just this broad thing that encompasses everything, right?
Mhm.
And so we needed something that really defined what we did, what our product did better. And so APM, Asset Performance Management, is, to us, it's about understanding what's going on in the equipment, pulling that information in, and being able to use it to manage those assets.
So was there a customer that drove this need? There was a specific customer that said, hey, you're giving us a turnkey machine build. Can you also include asset performance management as part of that build? Is that what happened?
No, it actually came from, so when we were building these machines, we built a couple machines for a plastics manufacturer. And they were making lids for Tropicana orange juice. And we built 5 machines, $1.5 million worth of equipment, delivered it to site, ran off, everybody was thumbs up, got signatures, got paid. A couple months later, we go back and want to find out what's going on with the machine, want to get a new contract for something else, and we find out that the equipment's not even running. And so we were like, what the heck happened? You know, what's going on? So at that point, I realized there's just no way that us as a machine builder can't understand what's going on with the equipment that we're selling. And that really is what started it. They were going to lose this contract. They had a contract to make millions and millions of these lids every year, and they were getting ready to pull this equipment out. Come to find out, it was just they didn't know how to set it up correctly. So we would have had that visibility if we had Automation Intellect then.
So there's another company, are you familiar with Oasis? Oasis Testing, they're here in Texas.
Mm-hmm.
So the president of their company is a guy named Dimitri White that we've been working with. Oasis basically makes testing equipment for device manufacturers, right? So if I make a hydraulic valve, or I make a hydraulic cylinder, when I make a new build, that has to go through unit testing and stress testing. Oasis Testing makes the test systems that they use, the actual equipment that they run up the temperature and do these they do these tests and measure the impact of failure, that kind of stuff.
Okay.
Oasis is doing the exact same thing. We're having the same conversation with Oasis right now that you were having with the machine builder company, and that was it's not the customer who's asking for this level 3 or level 4 data. It's Oasis Testing. He's saying, listen, we want to know how well because they also build test systems for their customers.
Yeah.
And he says, we want to know how well our test systems are performing over time. It's not the customer who's asking for it, it's we want it. And then we want to pass that value on to the customer. And I think it's there are a lot of company, or a lot of people in the community don't understand how much of IIoT is driven by the engineer or the machine or software developers who make the products that are being used to automate solutions. It's the reason that manufacturing in the United States found a resurgence when American companies who would engineer machines here in the U.S., then send them to China, and they'd just be turnkey, and they'd make washing machines or whatever. It's the whole the hot water heater. Was it Kenmore, I think? You had the hot water heater thing. They could build a hot water heater for $1,500. They designed it here in the States. They sent it to China. And for 10 years, they made it for $1,500 in China. And they said, well, we want to be able to make it, we want to do an improvement to the hot water heater. So they took a production line, they brought it back to the United States, put it close to the engineers who do all the process improvement, and their goal was to reduce the cost to like $1,200, and they were able to reduce it to $800 per unit.
Wow.
And what we learned in the United States through that process was that having our machines close to the engineers who design them provides value that we can't quantify early on when we try to go capture, hey, I just want to go get cheap labor. Well, there's a cost to go getting that cheap labor, and that is the continuous improvement component that we get through staying close to the system.
Yeah.
We lose. We lose all that value, and over time, that lost value hits our bottom line exponentially. There's an exponential cost to it because it is compounded interest, basically. The continuous improvement is a compounded benefit, year over year over year, as opposed to cheap labor is a static benefit that doesn't compound. It's fixed, it's cost, it's a savings captured one time on every hour, and it doesn't exponentially impact your bottom line for the greater good.
Makes sense.
Right? And so it's a broad spectrum statement, right? But at the end of the day, it's continuous improvement, right? Across continuous improvement to improve our processes, across the board to continuous improvement where we have to capture information in order to even learn what we want to do to improve the machine, and which is where you guys come in. So when was Automation Intellect created? How long has the company been?
Company's been around for about 3 years.
Okay.
We really were shoestring kind of funding it in the beginning. Just myself and one other guy were putting some money in to keep it going. We had some software development going on. Our CTO now, Kurt Luke, he's the one that's kind of been with us from the beginning doing the development piece. But that's when it really started. And then last year we raised a round of seed capital. Raised a little over $2.25 million last year. That's really kind of helped fund our growth from there.
So how many installations do you have? Is it global? Is it across the United States?
So more or less southeast so far.
Okay.
We've got two or three tier 1 automotive customers. We're kind of focused in the automotive space for now.
Okay.
Not that it's not applicable outside of that, but it's something that I'm familiar with. It's kind of where I grew up to some degree, so we focus there.
What is Automation Intellect's core value proposition to the market? Right, there are lots of solutions out there, and we're going to talk about IIoT in a second and how even the definition of IIoT varies depending upon who you ask, right? But across the market, there are thousands and thousands of solutions out there, and everyone is saying that they've got the solution to digitally transform your business, and we've got the solution to optimize your processes. In a nutshell, what is Automation Intellect's value proposition? What differentiates you from everyone else who basically connects to equipment and does OEE calculations?
So I think there's a couple key things. The first thing is time to value. So we can get connected extremely fast.
Right.
We can get the data and visualizations in hours, really.
Mm-hmm.
So I think that's number one. Number two is we've really taken the approach that you can't just provide pretty pictures. We've got great graphs, we've got great, visualizations, whatever, but that's really only step one. So we have to really have the customer success piece of it that comes after that to help them take the information that we're providing and then use that to improve the process, use that to improve their piece of equipment, whatever it is. And so the first step of our software is really the visualization piece, but the stuff that we're working on now is all around performance culture. It's all around how do we make the companies perform better? How do we make their equipment perform better?
Not just talk about how the information can be used, but actually use it.
Yeah, exactly.
Right. For example, the OEE calculation, when you put it on the plant floor, so say I've got 10 pieces of machinery, and I go ahead and I deploy an MES solution, or I'm just going to do OEE. We're not even going to do MES. We're just going to do the OEE component of MES, right? And I go ahead and I throw availability, quality, performance, and OEE up on a screen for 10 machines. So I've got 10 screens. Each of them are showing the current OEE, AQP, and each operator can see all the screens, right? So it becomes a competition between operators. We know that, right? And we can actually quantify the gains that are captured. So I'm going to ask you your numbers here in a minute. What do you generally see when you first plug into a machine? But let's say I see X as my baseline OEE the day I plug it in. In our experience, generally within 4 to 6 weeks, we are X plus, we'll say X plus 30% in gains in OEE, just by virtue of giving them a number. And it's amazing, I don't know if you experience the same thing, but whenever I tell executives this, when we show them these charts, they
They don't believe it.
They cannot believe they
can't
will
believe
capture
it.
those gains
Right.
just by virtue of providing the number to their people. Just the number to the operators. That's before you ever even make that number available to supervisors, managers, engineers, the quality department, all that stuff.
Yeah.
You're capturing huge gains. And so that's it's immediate time to value. Now, we're going to talk a little bit about your architecture in a second, but why do I want to talk about Automation Intellect? Here's what appeals to me about Automation Intellect. There are a lot of companies that reach out to us. So, hey, would you take a look at our product? Let me know what you think. There are a lot. And Zack can tell you because he reads all my messages on LinkedIn. We're probably talking to 1 out of 50 companies, I would say, that reach out to us. When Kate originally reached out to me and said, hey, would you take a look at this? And I think you and we had a call, I don't know, maybe 6 months ago, 8 months ago, something like that. And but what appealed to me about your solution, A, is that it's edge driven. Sorry, it meets all of the criteria, right? So to be an IIoT solution, it's got to be open, it's got to be edge driven, it's got to be report by exception. You guys meet all of those criteria. So you have an E1 device out on the edge. That E1 it can talk anything. Obviously, you have objects that run inside the E1 that are then streaming those objects into the cloud, right? And then in the cloud you have a data store, and you've got an engine, and then you've got a UI interface that sits on top of that presents the data. So in a nutshell, that's the core architecture, right? But then you can also add on to that, so that you have those red objects they just evenly map to one another, right? But then you can also add in additional value down the road. What I was blown away was when Kate was telling me the numbers about, when you talked about the time to value piece, Kate was telling me about some use case where you guys were doing, 100 machines. You provided like visibility to 100 machines in 6 weeks from start to finish,
Yep.
right? And those numbers are unheard of, right? I mean, granted, it's the OEE component, but that's still an unheard of number to be able to install that many units and provide visibility, the OEE calculation visibility in 6 weeks for 100 pieces of machinery. And what started to appeal to me, what I started thinking was, one of the biggest challenges you have in an MES enterprise system is time to value is not short.
Right.
It's long.
It's months.
Yeah,
right?
yeah, it's months at best, because it takes time to build that application. Even if you build it homogeneous and heterogeneous, where I've got a framework, I've got the homogeneous component, which is the object-oriented development like you guys do,
Yep.
and then heterogeneous is that blue stuff. It's all the custom stuff for the customer. You still can't do 100 machines in 6 weeks. We do them faster than anybody else in the market, but 100 machines is still going to take us, best case scenario, 4 to 6 months to get 100 machines in. Maybe 3 months at absolute best. If we're lucky, it's 100 of the exact same machine. She was telling me this is not 100 of the same machine. This is 100 different machines.
Yeah.
And we're able to provide visibility in 6 weeks. So when you start thinking about that, you go, hey, listen, if we bring Automation Intellect into the ecosystem and we can provide OEE visibility for 100 machines in 6 weeks, that buys you, that's equity. That's project equity,
Yep.
right?
Yep.
I've provided the visibility. Now we can go ahead and take out.
Bring the MES back in.
That's right. We bring in the work order management component and all the non-OEE elements of MES, while they have OEE visibility and capturing that 30% gain just by showing the visibility, it becomes a profound argument for using your solution as the OEE component in an overall IIoT infrastructure.
So I have a question. So that's why Automation Intellect appealed to Intellect, but why did Intellect appeal to you guys?
It kind of the same thing on the other side. So we're able to do this one piece that's OEE, but a lot of times the customers want process authorization. They want some other MES functionality that we really don't have. We're kind of heading towards each other, right?
Mm-hmm.
You guys are heading downstream towards the edge, and we're heading from the edge kind of
That's
up
right.
the other way. And so it's just, to me, it's the right match. It's
Awesome.
You've got to have the MES. Most of the big companies have some level of MES in their manufacturing facilities. And not a lot of them have OEE visibility, really. In fact, one of our recent customers, they had been installing MES for 2 years. And we said, well, this is great, but why are we here? You know, why would you even need us? And they said, well, we can't get a report. We don't have any visibility to what's going on. Yeah, we get process authorization at each station, but we have no idea what's going on.
And this is the conversation we had just last week or whatever. It was, hey, you know, Walker, we have this tier 1 automotive supplier we're talking to, and they really like our product. And but there's somebody else there who's talking about ignition or whatever it is, and why not just do it all in ignition? And you actually asked the question, why not just do this all in ignition? What is the reason that we would want to? And my answer was, hey, no, there is a really strong argument to be made here to use Automation Intellect as part of the ecosystem for the OEE calculation. Not only that, the level 4 dashboarding as well. There's a huge argument to use Automation Intellect for that level 4 dashboarding component because A, your time to value, B, it ends up becoming an underlying, it becomes the underlying foundation of the architecture. I mean, one of the things we don't do is I don't want to say we don't do this, we don't do it in every application. We don't install edge devices in every application. But every single one of yours has an edge device.
Yep.
Every single solution you have is an edge device. Now, those edge devices don't have to be machine specific, right? You can group multiple machines into the same component. So
it really depends on tags.
Right.
So for us, the edge device has a certain capacity to manage a certain number of tags.
walk us through a typical engagement. So I'm the customer. We sign the PO, and it takes. We've established it can take time to value. I mean, Kate was telling me sometimes time to value is a week. You guys can do a solution in a week, up to bigger solutions, which are 6 weeks, and obviously that's the first phase of the engagement. But walk me through that engagement. What does it look like? What's the experience like for me?
So, do you mean POC versus more of a rollout, or you mean?
Let's start with proof of concept. Let's do proof of concept.
So, typically what happens in a proof of concept is we identify a set of equipment, whether it's a line or a specific piece of equipment, whatever. Then we will collect a bunch of data or a bunch of information from the customer. So we get PLC code, we get HMI code, we get types of products that they're going to run on the line. We get all of that information up front. Then while they're putting the drops in place, so they'll drop Ethernet cables or whatever to wherever they need them, in that time frame, we take that information and we create the tag list that we need. So we pull it, our team pulls that out, and then when we're ready to go, we send them the E1. It's pre-configured, so they can plug it into the panel. As soon as they have connectivity out, the data flows.
Okay.
So,
what are you finding the connectivity piece? What is that typically over their corporate infrastructure, or is there cellular options?
There are cellular options. There are Wi-Fi options. Most companies are doing it over Ethernet that we've seen.
And you doing a combination of on the business network and on process networks?
Typically, so the places that we've been, they've broken it up. So they've had their production network, and then they've had their business infrastructure. We're usually on that process network.
Okay, good. Let's talk about the open architecture components of it. So you support OPC UA from the edge, MQTT. What other protocols do you talk outside of the drivers to the PLCs between the edge device and the cloud or other solutions? Is it primarily OPC UA and MQTT?
So what we're doing right now, it has the capability for those. Right now we're using a STAR certified architecture that's part of the E1 architecture.
Okay, got it.
And so we essentially we pull the tags in. And
your cloud solution sits inside is in the STAR network.
We API out of the STAR network.
Okay.
So essentially what happens is that data comes into the E1, we create a JSON file that gets pushed to a mailbox that is inside the STAR architecture, and then we pull it up with an API call from our system, from that mailbox.
And that's a that's an open API. It's REST
It
or
is.
SOAP or
Yep.
so other solutions, right?
Can talk to
That's
it.
right. And then you also have an API at the cloud layer. So after the data's been post-processed, you can either retrieve the data from a database or you can retrieve it from a software API that you have in the cloud as well, right?
It's our whole, and some of this is getting a little over my head.
Right.
Everything that we've done has been built around APIs.
Okay.
So we have the ability to call into any different part of our solution. We're looking at some of the machine learning stuff, and we've got like a EDW, data warehouse, and then a data lake for the machine learning section of that, that we can write stuff down to the edge.
Okay.
So
What other solutions do you provide, or what are you planning to provide, in addition to OEE visibility?
So a couple of the key ones we're working on right now is Plant View. That'll be rolling out here in a week or so. And essentially what that is a roll-up of all of the individual pieces of equipment or lines in the plant to a plant-wide view of performance.
Okay.
We highlight the worst 3 performing lines. It's more of a real-time display of what's going on in the plant. The next thing that's coming in about, I don't know, maybe 3 months or so, is what we call performance culture. And essentially what that is inside of our software, you're going to be able to tie tags to like a Kaizen or a Lean event that we're building inside of our software.
Okay.
So you can track the data, you can track the actions, you can tie that to the piece of equipment or to the line, and then you can roll that up into initiatives or into overall goals for the organization.
State. So let's talk about state from the machine real quick, because you had mentioned the Kaizen. Kaizens are generally driven by choketes, and so, for those of you that don't work in Tier 1 automotive, the Japanese are really big in Tier 1 automotive, and so and the American companies that are in Tier 1 automotive generally adopt Japanese terminologies and
Yep.
principles, right? The continuous improvement. So a chokete is a short downtime event. So we would generally call it like a nuisance event, a micro event, a really short one, 5 seconds, 10 seconds. The organization defines what that is. Anything less than X is a chokete. And then what they do is they look at worst performing lines, then they look at causality of the worst performing line, and that is either going to be long time down events, so catastrophic,
Right.
or it's going to be choketes.
A lot of choketes.
And if let's say they're seeing a lot of the same chokete, then they will develop a Kaizen, which is a continuous improvement element that is driven by the causality, which was the chokete. So,
And for those that don't know, Tier 1 automotive would be like your mass market cars, or
Tier 1 automotive is the stuff that they build. They are shipping to the manufacturer, the automotive manufacturer.
so one layer above like a Ford or a GM or something.
They are one layer.
Below.
Think of Tier 3 makes the micro components or makes maybe the cables and stuff. Tier 2 puts
parts,
Tier 3
maybe.
together, and then Tier 1 takes the Tier 2 and Tier 3 stuff, puts them together to create a fuel pump that they send to Ford.
Got
So
it.
Tier 1 is
Okay.
sending it to the actual, it's the part that goes in your car
Got it.
or your truck or whatever. So Tier 1 is the big, they're the big fish in automotive. And a lot of them use Kaizen for continuous improvement, a lot.
Awesome.
And so when you are developing enterprise MES solutions that are being driven on an OEE calculation, you need to know that all that data that you're turning into information is going to somehow find its way into a Kaizen
Yeah.
board. Right?
Random question: Is Tesla trying to be like all the tiers?
Yes.
Really?
Tesla is all the tiers, with the exception of they have
few.
they have a handful of tier ones. But now Tesla originally tried to do it the way other and
That's why they make 10,000 cars a year.
yeah,
Right?
they originally tried to use suppliers, but the suppliers couldn't meet their standards, and B couldn't meet their deadlines.
Right. So like now they make their own
They
electric motors.
they
and stuff.
basically make everything.
Yeah.
Yeah,
Wow.
they
But
do
they
get
don't have quite the content either that a normal automobile would have.
Right.
So
Right.
they have a lot less.
Moving
They're not
parts.
buying fuel pumps and
right
That's-
a lot
that makes it
fewer
really easy.
components.
components.
Which was
Right.
one of the things that Elon was driven by. I want fewer components in the car.
Makes sense.
Right.
How many parts are in a typical car?
So I worked
ICE.
I worked for a tier 1 automotive supplier. I was a manufacturing engineer for a product that I worked with the automotive suppliers, product engineer, or the automotive companies, product engineers. One of the vehicles that we worked on had more than 100,000 parts in it. 100,000 different components in it. But I would say I never personally saw anything that had less than 10,000 different elements. The bill of materials on a finished U.S. car is
It's crazy.
absurd.
Yeah.
It's
Wow.
absurd. Yeah.
So your devices and IIoT can obviously help all of those suppliers and
Yeah, I would say I honestly have seen no products that provide the time to value that you have, right?
Yeah.
Automation Intellect, your solution is it's not a platform, right? It's not a platform for solving problems. It is a solution to a specific subset of problems, right?
It's
What-
an out of the box,
Right.
plug it in and it gives you what you need without having to build anything.
But the big appeal is calculating OEE is not easy. I mean, you already know this, right?
Right.
There's a whole host of the reason I was talking about state is one of the big things that comes into calculating OEE is the first thing you have to do is you have to when we're looking at performance, we want to look at scheduled availability, and then we want to look at unplanned downtime and planned downtime.
Right.
And the way that we get that is through getting real-time states of the equipment.
Correct.
So how do you guys handle state? So are you using predefined state definitions that you apply to the machine? Is that how you do it? Okay.
Yeah, usually. We have essentially running, faulted, and stopped, so available.
Okay.
And there's other ones that are in there, but we tend to bucket them in those three.
Okay.
Um,
Can you add in your own definitions? So let's say I've got 5 alarms that I would like to see in my state. So I would like to see, instead of seeing it as stopped or faulted, I would like to know, is it one of these 5 alarms when it is faulted? Do we have that capability?
Yeah. So we kind of break that out. So there's the 3 states, and then if it's a faulted state, we capture the actual fault from the PLC.
Excellent.
So you get all of that kind of delineation between the faults and the actual downtime.
Inside the E1, how do you handle counts? So do you guys have lifetime counters that are running? Do you turn transitions from the PLC into counters in your edge device?
Most of the time. So
Okay.
we'll either take a counter, we can do it both ways. So
Okay.
we can either take a counter or we can take an individual data point and count it.
Okay.
Either way.
So people who do MES systems will appreciate that technology, will appreciate that approach. Those are the nuances of doing MES, where everyone says, "Oh, it should be easy to calculate." No, it's not easy because most of the time, machine doesn't tell you exactly the number of parts.
in the way you want it to.
What about rework? How does your system handle rework? If I'm going to go ahead and take a part that came off the end of line, and I've got to rework it and run it back through, how do you guys handle that programmatically?
So typically we have a manual entry screen where they can do, if there's an offline inspection or something like that, they can enter in the reject code or the reject reasons for that piece of product, and then it gets applied to the machine, and it's timestamped when they enter it on the handheld, and then we inject it into the data flow inside the software.
Okay, excellent. In the organization, who is, from the C-level down to the operator, what's the type of positive feedback you get from the levels of the organization once they have your solution?
So operator, it's easy to use, right? They don't have to do anything. Unless they're entering manual information, there's really no interaction that the operators need. They just run the machines the way they do. Next layer up, typically it's maintenance techs or people like that. They get a lot of visibility to why the machines are stopping. Sometimes it takes some cultural changes because a lot of times it's like, well, the operator told me it was blah, 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 whatever that is. Well, when you go and look at the fault reasons, it's never that.
That's right.
Right?
We don't trust people.
Yeah.
Never trust what people
If somebody tells you, I think that's what it was, that's probably not what
That's
it
probably
was.
not what it was, yeah.
So we are able to show those fault reasons, and then they can take that information and go fix something. And that's one of the things that led us to that lean Kaizen type approach is, hey, we're going to give you all these big bucketed items, go fix those.
Well, it's funny you say that because when I'm doing a presentation for a company about MES, one of the things that I will say is that once we complete this engagement, I said I'll go around the room and I'll ask everyone in the room, all the stakeholders, the engineers, the production supervisors, the CEOs, all that stuff. I'll say, what do you guys think your number one problem is? As they want to produce more for less. That's the goal, right? So I'll say, what do you think your number one barrier is to producing more for less? And they'll almost always, to a person, believe it's the operators. They'll say, if we could just get the people to come back from break on time or all that stuff, and I tell them, I promise them, I assure you it's not your operator. Your operator being lazy is not your problem. Every single person thinks believes that that's what it is. It's to an organization. We've never had an organization say, not point to performance. What they will find is that it's a combination of all three of those things work in tandem to one another.
Yep.
Maintenance, quickly getting the notification that a piece of machinery is down and accurately getting the information that they need so that they can fix it. The quality department actually getting the information as to what the defects are, and the operator accurately understanding how fast they're supposed to be running the equipment and when they're supposed to be running equipment. Those things combined is where you capture your efficiency gain. It's not getting your operator back from break on time.
And that's why the visibility is so important.
That's right.
If they don't know what's going on, it's really hard for them to realize that that was down because maintenance was
That's right.
the problem, or that was down because an operator didn't show up today.
What does the C-level tell you? The guy who signs the check, what's his initial feedback?
So they really want the visibility to the floor. A lot of times they're not on the floor, and so really understanding why that line was down or having visibility to see, oh yeah, that part of the plant is having problems today for whatever reason, I think is probably the biggest thing. They don't have the visibility, the real-time dashboards at that level typically, and so we give them the ability to kind of see it all.
What's the biggest complaint or the biggest, in your eyes, the biggest growth opportunity for your solution?
The thing we come up against in every place is change management.
Okay.
So people they've done it the way they're doing it now, and they've done it that way for 25 years, and you bring something new. It was funny, we had an installation where we put it in, and it was getting all of this great information directly from the PLC, fault codes, everything. One of the engineers says, we need to have manual entries for all the downtime. I'm like, well, the downtime's right here. It tells you why it's down, right? If it doesn't, let's put some things in there that tells you why it's down.
But capture the rising edge and the falling edge of the event from the machine directly.
Right.
Right, exactly.
But no, they want to have buckets of downtime. Oh, well, that was a material reason, or that was a this.
Yeah.
Well, it's right there. Just use what data is already coming in.
So much of that, I find, is plants are very used to manipulating their report, right? So, I mean, this happens all the time. We actually have customers, I'll say in the presentation, hey, listen, they're afraid of, sometimes they're afraid of the wrong people getting the right information, right? Sometimes they're afraid, and there are times where we'll say, listen, if you're uncomfortable with your executives seeing the truth, we're happy to build you 2 sets of dashboards. So when they come to a plant view, you can turn on the executive, but you still need this. And this is information you need to improve your processes and become more efficient. And if you feel like you need to control that and not let that move up the chain, we're more than happy to create 2 sets of dashboards. But promise us you're going to get this information. You need the truth to get better. But it is amazing the number of people who. And a lot of that's driven by, well, I want to be able to blame, or I want to be able to assign blame to a different group. That's the reason they want to have control over, for those that are not OEE people, availability, quality, performance. Availability, when the availability number is low, when the OEE number is low, you yell at the plant manager. When the availability number is low, you yell at the maintenance manager. When the performance number is low, you yell at the production supervisor, and when the quality number is low, you yell at the machine builder or the engineering group, right? The AQP and OEE, those numbers were calculated so that you know who to hold accountable,
Right.
which group needs to focus on improving, and as such, there is a lot, and I'm sure you see this. There's a lot of manipulation.
Yep.
That is, I don't want that to ding my performance number. I want that to be downtime. The favorite thing of what they want to do is
Well, they're kind of in
turn everything into a planned downtime event.
Right. It's like, well, we ran out of material, so we're down today.
Yeah.
No, that's downtime.
That's downtime.
right.
That's right.
You don't get to count that as unplanned downtime
Right.
now because you don't have stuff.
That's
Well,
right.
Why lie to yourself, you know?
Well, because someone else, if you're the only one who's going to see the information,
No, it's the
you have no
order.
problem.
Right.
It's irrelevant. But it's when it's going to go up the chain and you're going to be held accountable.
Well-
You get a lot of that resistance. And if you're going to do MES systems, you're going to do OEE,
Yeah.
you need to know that's the type of resistance you're going to see.
Well, I could see a lot of these different areas kind of overlapping. Like the machine might break down more if you're running bad quality product through it. You know what I'm saying? So is that really the maintenance manager's fault, or is that the quality department? You know what I'm saying?
But that's for the quality manager and the maintenance manager to come together and
Right.
decide
You got to work together.
what the solution is, right? At the end of the day,
It's just OEE.
that's just
Right.
OEE. That's
So
right.
wherever it comes from,
Right.
everybody's responsible for that number.
That's right.
And a lot of times I think we'll walk into a plant. Yeah, we're running 85% OEE.
Yeah.
And you're like,
no,
no,
you're
you're
not.
not.
No, you're not.
No, Matt?
I promise you, you're not. Yeah. You
That is
are-
actually 80% is like a world class.
85, yeah. It's
Yeah, 80,
world-class.
85 is world class. Give us your when you first plug in. What's the typical number you see? Give me the average.
I would probably say between 50, probably around 50.
Okay.
Plus or minus 5% from 50.
I would say generally we're seeing something in the mid 30s to the mid 40s in general, and we're generally in that first 60 days. They're immediately moving to 65 to low 70s, and their goal is generally 82 to 95, something like that. We tell them all the time, listen, if you get to 95% OEE, you're operating in a space that very few companies
You're probably
are operating.
calculating it.
Yeah, and if you're operating in 95% OEE, then we need to start calculating TEEP immediately, and you need to start making your decisions
For purchasing
on your
assets.
TEEP number. That's exactly it.
So
yeah.
that's making more planned, scheduled runtime, or
Or buying
unplanned.
more equipment
Buy
to
more
add
equipment.
capacity.
Got it, right.
When your OEE number is that high, then it means you can't. Capturing efficiency gains isn't going to capture you much.
Got it.
You need to start building equipment so that you can handle larger orders.
Yeah.
The OEE came from the whole idea that I just got an order for 25 million widgets.
Rather than buy a new machine.
Do I need to build a new plant, or do I need to get my people to work operate more efficiently? Well, I can't make that decision unless I have visibility to how efficient they are. TEEP is based on a 24/7 number. Like if I ran 24 hours a day and 7 days a week, how much could I produce?
Yep.
And OEE is based on the schedule. So if somebody wants to get a hold of you, if they want to see your solution, if they want to learn more about automation, if they just want to learn more about OEE,
Yep.
how do they go about that? Other than going to automationintellect.com, that's your website, right?
That's our website. So OEE.com gives you all kinds of information about OEE. Every definition, what should be included, how the things are supposed to be calculated. And then, we have tons of content out there for comparing OEE versus other metrics.
Well, let me ask you this: why are you? I believe OEE is the best number
Yep.
to use, and obviously you do too. From your perspective, give me the reason. Why do you think OEE is the best number?
I think, so we're focused in discrete, and OEE is a very useful, every part of it, like you just talked about, is very useful to understand what's happening on the machine. Where are your problems coming from? Where's your quality problems coming from? Where's your downtime coming from? Whatever it is. And so really having that metric, I just don't know what else you'd use.
Mhm.
It really has the most information in one number. And it's the most, it's the most generic, right? It can work for anything. It can work for a company making baby bottles to making automobiles.
Yep. And one of the challenges, one of the things we see all the time is doing enterprise systems. We don't generally put an MES system into a plant. That's generally our proof of concept. But then we generally move into enterprise solutions. one of the biggest challenges that we see across the board is various business units may want to calculate OEE differently. You know, and I'm sure you see that,
Yeah.
right?
Yeah.
Well, we don't calculate it that way.
So
Yep.
you said OEE.com. Is that a website that you guys put out, or just a
No, it's
another
just
resource?
a generic.
Yep.
Yeah, I've
it's
used, that's a
resource.
great one I used for building my OE systems
Yep.
back in the day.
Yeah.
The biggest challenge is that when you're doing these types of systems, you have to stand very firm on, hey guys,
Yep.
you know, a downtime event is this, a rising there's an actual rising edge and falling edge of an event, and we don't play with those numbers. We can split that into multiple events if you want to. Hey, the first 5 minutes was this, and the second 5 minutes was this other reason. You can do that kind of stuff, but you can't change the rising edge and falling edge of it. You can't change the way OEE is calculated, and the reason why, this is really important. The reason why is because that is that measurement is important to compare business units and plants. Yeah. Imagine if the NFL allowed you in one game you got 6 points for a touchdown, and in another game you got 4 points for a touchdown. Well, if we watched SportsCenter at the end of the day, and they were telling us the scores of the games, and we saw one of the scores was 160-3, and they didn't tell us that in that game the team that scored 160 points, they got 20 points for every touchdown. They didn't tell us that. As fans, we would have no idea what we were looking at. Right. That is the impact of changing exactly the way you calculate OEE, because you'd be looking at scores apples and oranges. You would not. It's not congruent across all of your machines, all of your lines, all of your areas, all of your plants, and all of your the whole enterprise. Wow. That's the reason it's so important to stay committed to it.
Yeah, and in our software, it's the same everywhere. Yeah. So if it's a machine, we calculate the same as if we do for a line, we do for a plant.
Excellent.
And
do you time bucket? Do you do counts and time like to the minute? Is that how you do you bucket it into minutes and then do calculations that way? Is that how you're doing it?
I mean, it's literally to the second.
Okay.
And then we're rolling it up.
Oh, rolling it up from the raw second
from the raw data.
Event data. Okay, cool. Yeah. Very cool. I actually didn't know you guys did that. Our MES system does that, but I haven't seen another one do that. Because it ends up being so many events, so many count transitions.
Now we do aggregate it,
Yep.
So once you get an hour, it gets rolled up to an hour.
Oh, into an hour table.
Yeah.
Okay.
Now you can go back to that detail level, but once it's aggregated up, we're looking at the days or the hours as a roll up.
And just so we're clear,
it loses value beyond that.
You can query the actual raw event data, and there is an API that allows you to access your calculations, right?
Our calculations are behind the scenes, so they're not operator adjustable.
Right.
We do that intentionally. Is that what you're asking?
What I mean is, we want to visualize. What we want to do is we want you to do our OEE calculation for us, and then we want to put it in our dashboard, not in your dashboard.
Yep.
Who's the technical guy?
Kurt.
Kurt, there you go.
Yep.
And Kurt had said in an email earlier in the week that we can retrieve. You can do the calculation, and an external application can retrieve that calculation and put it into our unified namespaces, which is what our plan is. We're basically going to take, architecturally, our plan is to take your OEE calculation and put it into our unified namespace.
Yeah, you
nice if we could also publish via MQTT to our broker.
Which they can.
That'd be sweet.
But they publish from the edge. It's MQTT from the edge, but not up in the cloud yet, right?
That's a Kurt question.
Okay.
Yeah.
Yeah, they can publish from the edge already.
So, sorry, what were you going to say?
No, I was just going to say the OEE, we'd pull that directly from an aggregate table. So you'd be able to see the rolled up hourly version or whatever and push to you guys.
So 2 more questions before we close it out. So number 1, the prevailing trends in the industry. What is the, you talk to as many people as I do, what is the number, if you were going to say, I feel safe saying manufacturing is going in this direction, what direction is that?
Almost every company has an Industry 4.0 initiative, right? I think there's a lot of hype out there. People are talking about augmented reality, their virtual twins, or
They're putting the
digital
horse
twins.
before the cart there. Yeah.
Half of the companies can't even handle the data that we're giving them now. So that's like 3 steps down the road. everybody's digital, taking the information that they have digitally now and making it visible. I think almost everybody's doing that. I think the next piece is how do you really get value from that? They got to be able to take that information and create something that's more productive than it was before it.
Like
Otherwise, you're going to lose.
culture.
Yeah, well, performance culture, it's just, in general, if they invest all this money in adding all these digital systems and they don't have a better result, then how do they do the next plan?
Right.
They have to be getting results from what they're doing. And some of it they do just from the visibility, but a lot of times that's a momentary bump because people tend to fall back into their old habits.
We did a survey 2 years ago. I funded a survey. We actually have it in a PowerPoint presentation. We took the automation stack and we sent out the survey to 1,000 manufacturers in the United States, or I think it was global actually. And we asked the question, just answer these simple questions. Do you use PLCs? Yes or no? Do you have a software-based SCADA system? Yes or no? Do you have a software-based MES system? Yes or no? Do you have a software-based ERP system? Yes or no? And do you have a software-based cloud computing, big data, or machine learning initiative? Yes or no? The MES system came back with less than 10% of all respondents had a software-based MES system. Okay, that number has to be in the 80s or 90s before we can start talking about augmented reality. Before the market can support solutions that are going to be cost-effective as it relates to augmented reality and artificial intelligence. The reason we talk about the stack is the vast majority of people's MES systems or OEE calculations are sneakernet. Vast majority, 90-95%. There just aren't enough people out there yet who have done software. You're filling in that gap. We're filling in that gap. Other companies are filling in that gap. Traxxas and Ignition and Flow Software and Factory Studio, and they're trying to fill in that gap in the MES layer. I think a lot of people will ask the question, why isn't it going faster, right? And the answer is there were a lot when companies in the late 90s and the early aughts were putting in their first SCADA systems. So the first centralized supervisor control and data acquisition and alarm management and visibility of the whole plant. There weren't a lot of failures in those projects. When they did that project, they had a lot of great turnkey SCADA systems sitting in the control room when they were done. 90% success rate when you did that. In MES, it's inverted.
Right.
The number of MES systems that are successfully deployed is a fraction. It's a fraction of the total projects that are attempted. You see that, I see that. And the reason why, it has so much to do about the details we talked about today. How do you handle state? How do you handle counts? How are you doing the calculations?
How do you get connected to the edge?
How do you get connected to the edge? How are you transferring the data across the networks? Those are the reasons those projects are unsuccessful, because there are so many cost overruns in those solutions. Right? And whereas in SCADA there was lots and lots of success in those projects, so there was wide adoption. Well, we have a lot of failure in the MES layer, which is hindering. And what's crazy is MES is something that should have been digitized a decade ago, 15 years ago, and we're 10 or 15 years behind schedule. And we have to have that layer fully digitized, or at least we have to have 80-90% adoption rate before we can seriously consider cloud, machine learning, and AI. What everyone's trying to do is circumvent that middle layer. They're trying to go directly from the edge into a data lake to machine learning and AI. And the reason those projects fail is because they don't have the contextual data that comes from the MES layer. They don't understand that you're not going to do OEE calculations from a data lake. You need a solution like yours who's going to go ahead and is going to normalize the data and do the calculations and then apply that. These are the technical challenges to wide adoption.
But you also need that MES data in context with the real-time data, so that's why you need the unified.
And guess what? He does the calculation. He doesn't do the calculation as along with the real-time event.
Right.
He does the calculation after the real-time event, after some interval. And so what we have to do then is take your calculation and apply it to a group of real-time events. And when you get into in the cloud, when you get into machine learning and AI, the real skill set there is taking all the timeline of your real-time events and your calculations and getting them lined up on the chart so that we can then look for the patterns that we need to then say, oh, I've seen that pattern before. We have an impending failure coming, right? And that's the challenge that we see.
And a lot of times you don't have that data down that far either.
Right.
So even though you can see that an event happened, you might not know that a bearing broke or a cylinder got screwed up.
And
or
imagine
something changed.
one time they don't tell you that. One time they don't tell you it was a bearing went bad, and now your data is not good anymore.
Right.
If you're relying on the mechanic to accurately tell you what the cause was,
happened? Right.
then now that data can't be used in the pattern matching grouping. Yeah, and they call it training the
We're bootloading the AI.
yeah.
It's a lot different too when it's process. If you're looking at a process like SCADA used to do, right? You were able to kind of see the way things work because it was more of a continuous process. With discrete equipment, it never works like that.
That's right.
Interesting.
You know, you'll get a piece of discrete equipment, it's running and then it's not running, and it could be something jammed or it could just be they ran out of product. I mean, there's a lot of variety there that makes it much harder to do AI.
What's the future of automation intellect? That was question number 2. So the future of your company. Where you're a strategist as the president of the company.
Yep.
You know, where are you a year from now? That we know some products that you have or some advancements that you got coming in the next few months. If you want to go over those again, you can. Where are you in a year, and tell me where you are in 5 years.
So, to me, this is all about value, right? So every product or module or whatever it is that we're building has to be adding value to the process. That's why we're doing performance culture, because we've got great dashboards, but if they don't use them, if they're not adopting product, then we're not providing value. Same thing with the next step. Digital twin is on our roadmap for late this year, but in a way that delivers value. So we want to be able to say, hey, if we fix this fault, what would our production have looked like? Or if we fix this fault, how much additional capacity will we have going forward? And then it's coordinating all of the data pieces together. I think it's a lot of little specific things. So we have companies that have a lot of changeovers. So how do we identify the
Some of them
best path?
Some of them make all their money simply because their value to the market is they've mastered the changeover.
Right.
We can do short runs better than anybody else can do short runs because we're really good at the changeover, and that's our value in the market. But it is a nightmare for systems like this.
So we have a tool or an analytic that we build that distinguishes between changeover. So when they select a product change, we keep track of machine stop time to machine start time, and we find it in the data. But the other thing is when do you go from some percentage of ideal run rate back to percentage of ideal run rate? Because a lot of times they have a changeover that takes them a half an hour, quote unquote, but they don't get back to full production for an hour and a half.
Right.
So you were really running at much below your capacity for that time, and identifying what's happening during that time.
And it's those gains that you can capture in that window is the justification for investing in a better machine build up front. But it's the number the executives and the engineering manager or the director of engineering never sees prior to scoping out the machine build, which was your original. There are so many, I've tried to make the case in the machine build so many times as to why it is we should make an additional investment of 10 grand or something here in the machine build to capture hundreds of thousands of dollars in gains down the road, but you don't have that data to make the argument. That is, just this one change in the machine build can get us to ideal run rate faster after changeover than by them having to tune this one piece of tooling every single time they change over. And it's data that decision makers don't have, or it's information that decision makers don't have.
Kind of got like a just far out there question. Do you think, like self-driving cars with the Tesla uses like vision cameras to perceive the world around it. Do you think like certain applications in MES and production lines will start to implement cameras to be able to use AI and machine vision to detect reasons that are not easily detectable by a discrete signal?
Yeah, I think they already do to some extent. There's a lot of cameras that are doing quality inspections.
Oh yeah.
But I've seen a few products that they're using cameras to determine operator movements.
Oh yeah.
To say part was loaded, and then the camera inspects that it was there correctly, and then it was
Wow.
done.
So it's already happening.
Yeah, I think it is happening. I think there's other places to get gains
Right.
that are easier.
I'll echo on the quality piece. That's been, with vision systems, that's been in place for a long time. In fact, there are a lot of applications where you're getting go no go on the part from the vision system.
Right.
So, but one of the newer applications for cameras in process tracking is counts. So I had never really gotten part count numbers from a vision system. I never got total part count numbers. But I was getting bad go no go, and we were tracking counts somewhere else. There's a much more, especially like in systems where you're using, like in a punch press. Say a punch press. I may have one strip of raw material coming in, but I may have a 3-out die. So 1 stroke equals 3 produced parts. The way that you used to do that was you would have to know, you would need a piece of metadata. How many out? What is the ratio of in to out? And then every stroke you would count 3. But a more accurate way to do it is to use the vision system to tell you the exact number of parts that came out on the back end, which is it was a triple strip, right? And so we're doing a lot more of that. I would say that that's something I'm seeing a lot more, where we're getting all the counts from the vision system and not using the process stroke to
Makes more sense.
yeah, makes a lot more sense.
We have that issue now, and we need operator input to tell us how many are coming out.
Wow.
And that one little factor can completely derail a solution if you don't have a plan to attack it. I mean,
It kills your OEE. You have no idea what your number's supposed
That's
to
right.
be.
Yeah.
Because you're either running 3 up or 2 up or 1 up.
Yeah.
So people who don't know OEE or how to apply OEE think it's much, they think it's much easier to accomplish than it actually is.
Right.
It's the reason that there's so many failures in these solutions. Right?
Interesting. It's where the theory meets the real world.
And then 5 years from now, Automation Intellect. What is Automation Intellect other than you're out of the Southeast, you're global, and what does the company look like in your mind 5 years from today?
I think eventually we get to a point where it makes sense to roll into something else, either an MES or some other higher level system, ERP system.
Okay.
I think that stuff's already happening in the industry. SAP is buying components that go into all these different niches.
Mm-hmm.
I don't think we want to turn into an MES. I don't think we want to turn into an ERP. So we either stay focused on delivering new value-based solutions, or we get bought by somebody or roll up.
Well, what I'll say is, you guys take the approach that very few companies are taking, and it's the reason we wanted to have this conversation. Right now you offer a subset of a single layer in the stack, in the MES layer. You provide OEE visibility plus. There's other stuff you provide, but it's the OEE visibility plus. But the thing that appeals to me about your company is you're edge driven, you're open, and you report by exception, which that is the fundamental underlying architecture of any successful IIoT implementation, and it puts you in rare company. That's the reason we're having this conversation. So, Brad, I appreciate your time.
Thank you.
I'm glad we were able to finally work the whole thing out. If you guys are interested in checking out Automation Intellect's solution, it's automationintellect.com. Again, Brad DeMarco from Automation Intellect, and we'll see you guys in the next podcast.
Peace.
Great. Thank you.
All right, awesome job.